After Edison's lamp was the reason we question the nature of the atom. And the nature of everything is around us. This doubt had to turn into certainty. What are we? What are humans? Are we real and our bodies are real? Or are we just waves in the space of the universe? Therefore, there was no more important topic for scientists to search for an explanation for. Scientists thought that they would repeat the experiment that took place in the 17th century. Through it, they knew that light is a wave. But this time, they experimented with the electron. This experience is called the double apartment experiment, and it was like the spell that got the genie out of the lamp. In 1801, Thomas Young brought in a screen with 2 holes of light, or as they called, slots. He passed a light through them and received that light on another barrier, and noticed the shape of the light that formed. The light, which Newton considered like little balls, had to pass through the 2 slits to form 2 lines on the other barrier. Who greeted them, but did not happen. Light passed through the 2 holes and formed a group of bright lines separated from some group of dark lines. Thomas Young stated that the explanation for this is one of 2 things. Either this barrier is hunted, or that Newton erred and light is not material and is waves. Just kidding, nothing is hunted. But why, when he saw this figure, he stated that light is waves? For example, water waves have a disturbance that moves the waves down and up, or in other words, it has tops and bottoms. If you make another wave close to the first wave, they will interfere. If the crest of the first wave meets the crest of the second wave, they will overlap and form a larger wave, which in this case is called a constructive wave. But if the top of the first wave meets the bottom of the second wave, it will destroy each other as there was no wave. The wave in this case is called a destructive wave. That is why Thomas Young stated that light is directed, because the light wave, when it passed through the 2 holes, formed 2 new waves and they interfered together behind the barrier. And when one peak met another peak, a large peak was formed through a constructive wave. It appeared on the other barrier in the form of luminous lines. And when the top met the bottom, they demolished each other, and a destructive wave occurred and appeared on the barrier in the form of dark lines. This is the idea of making noise canceling on a mobile phone. The mobile phone has a small microphone that receives the back earth noise around you. He transfers it to the processor, where it measures its frequencies and gives commands to the speaker that it emits sound waves with the same frequencies. Then he inserts the tops of the first waves with the bottoms of the second waves. It cancels out the noise around you during a phone call while you are in a crowded place, so that the other person can hear you. Scientists took advantage of Young's experiment, and instead of applying it to light, they applied it to the electron. In order to ascertain whether it is small and material balls, as I think Thomson, Rutherford, and Bohr, or is it a vector that has no physical matter, as de Broglie, Schrödinger, and Max Born think, they shined electrons on the 2 holes in the first barrier and observed the second barrier, and then they found on the barrier the same interference pattern that was caused by the light. Light lines between dark lines. If the electron is also directed? Then they thought, why don't they drop electrons one by one and watch the barrier and then see the result? Whenever they release an electron, they notice that it appears on the barrier in the form of a bright spot or a small ball. How does that happen? Where is the interference of the waves? Whenever you drop a new electron, it appears on the barrier in the form of a small ball. But after a certain number of electrons projected onto the barrier, they found that the electrons that appear on the barrier formed the same interference pattern for the wave. What is this? How does that happen? They put a monitoring device when it was opened from the two openings. Whenever the light passes through that hole, it will sound an alarm. They shed electrons one by one and found that the device beeps half the number of times. This means that half the number of electrons is once from the hole on the right, and the other half times from the hole on the left. And when they revealed the insulator, the electrons formed in the form of two lines only, and the usual interference pattern did not occur. So this means that the electron is not as directed as they thought. Someone suggested that they separate the monitoring device from the device and shed electrons and then monitor the insulator. They separated the monitor, then they shined electrons, and they observed the insulator. There, the interference pattern came back again, as if the electrons knew they were observing them. This is not normal. This means that the electron, while not being observed, is in a wave form or not in a material form. But if you observe it, it turns into a particle or a small ball. Thus, matter, if you do not observe it, it is a wave. But if you observe it, it turns into a particle and takes its shape. My hand is there because I see it and you see it. But if I hide it behind me, no one is watching it. It is a guide, or it is not there. So what do we do? Scientists gathered like players at the beginning of a football match. They decided that they are doing a conspiracy on the electron. They decided to put the monitor behind the two holes. In order for the electron to pass through its image, it is directed because it will not know that they are watching it. And when it passes through the two slots, each slot forms a new router, and they interfere, and the interference pattern occurs, even if the device is monitoring it behind the two slots. But when they did that experiment, they found on the insulator that the interference pattern does not appear, and only two lines appeared. This means that the electron, after passing through as a wave, knows that it is being observed. He changed his past, and as he was going to pass like a wave, he transformed himself into a particle and passed through the two holes as a particle, and only the two lines appeared on the insulator. This means that the future can change the past. What is that? And as we know that what applies to infinitesimal matters such as the electron, it is supposed to apply to very large matters like you and me. So when you meet a stranger you do not know and feel that you have seen him before, this means that you may have known him and lived with him, but something happened in the future other than the past. There is a very famous phenomenon called false memory. It occurs when people recount things and memories that happened to them in the past that they had not experienced before. Why haven't they already experienced it? We want to understand. There were a bunch of explanations to try to explain it. One of the most famous of these explanations was the interpretation of the many worlds theory. A group of scientists put forward the explanation that for every particle there is an equivalent that exists in a parallel universe. And those universes overlap in the event that I do not ask in which universe of those universes I exist. But when I start to ask about in what universe I exist, or do the observing and observing, all parallel universes disappear, and the universe in it remains. The interference pattern disappears upon observation. It's like a car is at a crossroads. Every road is in a different universe. If you don't watch the car will pass both ways at the same time. But if you start monitoring the car and start asking about the universe in which you live, you will monitor only one universe, which is the real universe, or the universe in which you live. The other universe will disappear and will not interfere with it, as if it does not exist completely. Calculate how many atoms and electrons there are in your matter, as each electron has an equal in a parallel universe. Thus, there are billions of copies of you in the parallel universes. Fortunately, most scholars are not convinced by this interpretation, until another interpretation appeared, called the Copenhagen interpretation. That's good. The Copenhagen interpretation was stating that there is no such thing as a place, and the electron is a wave, as long as the electron is not observed. When an electron is detected or observed, its location is determined. Scientists was convinced. But what is the nature of the wave, and where is the electron? And they stated, "Did you not know? The wave is not real. It's a wave of possibilities. It is not real. The peak of this wave is not a real peak, but it is the largest possibility of the presence of the electron that does not exist at the moment. But it is more likely that the electron will be present when it is detected. It's easy. And when this wave gradually descends from the top, the probability of the electronic presence decreases when it is detected as well. So when we shined the electrons individually, one by one, they were recording on the insulator a single bright spot, even when it is not monitored, because it was recording only one possibility of the presence of the electron. But after we shined a large number of other electrons, he recorded on the insulator the different possibilities of the presence of the electron in the wave. How can an imaginary wave have mass? Since the electron has mass, don't be in a hurry. This is what you will learn later in the quantum field episode. Einstein was not convinced by this interpretation. How can monitoring or surveillance be the cause of existence? He stated his famous sentence, "I like to think the moon is there, even if I am not looking at it." Schrödinger's explanation was that if I had a box with a cat in it and a bottle with poison gas, a radioactive substance, a radiometer, and a hammer, so that if the device measures radiation that moves and then moves the hammer, it breaks the bottle and releases the poisonous gas, and then the cat dies. Any moment I put the cat inside the box and then close the box, the cat will die, because the device at any time will read the radiation and will achieve this sequence. Unless you put only one atom of a radioactive element. This is how I entered into possibilities. I could not measure or monitor, and nothing was real. But let's see how when you use only one atom of a radioactive element, you enter into possibilities. Any radioactive substance that converts half of its mass into radiation within a specified period of time, it is called the half-life. If I have a kilogram of a radioactive substance and its half-life is 60 minutes, after 60 minutes, half the mass of the radioactive material will turn into radiation. That is, a kilogram after 60 minutes will become half a kilogram. After another 60 minutes, it will be a quarter of a kilogram, and so on. If I took one atom and had a half-life of 60 minutes, I wouldn't know when the other atom that was with it turned into radiation. Therefore, the atom that is with me can turn into radiation at any time within 60 minutes, maybe 5 minutes, 10 minutes, or 60 minutes. Since I do not know when the atom will turn into radiation, then I will not know when the cat will die, and I will be entered into possibilities and entered into a quantum trap. If you take that corn and put it with the cat and close the box, in 60 minutes the cat will be alive and dead, unless you open the box and look at the cat. Then the cat will choose one of the two, either alive or dead. This is Einstein's world of quantum. So if awareness or observation creates things, so if awareness or observation differs, will the nature of things differ? an important question that quantum mechanics is supposed to answer. And there is another question that we will know the answer to in the next episode. Is a person free to choose, or is he led? From a quantum mechanics point of view, if you want to know the answer to these questions, follow us for the rest of the series. Don't forget to like, share, comment, subscribe to the channel.